Hi guys, welcome to the Scalable Computing over the Internet. What is the scalable computing? Scalable computing means is handle can scalable growing. It's a key feature of scalable computing is scalability, availability, high speed, and last and finally low and accurate. Scalable computing main technology is virtualization, containerization, and low accuracy and availability and speed auto scalable groups. This is the use of scalable computing is game platforms and web apps and biological processing and analytics. It is use of main thing is backup and discovery recovery. This is all about scalable computing and is the main overall use about nowadays people active gaming platforms and use attractions and websites.
Scalable computing over the internet. At the end of this lesson, you will be able to elucidate the scalable computing over the internet, illustrate the age of computing. Over the past 30 years, there has been several evolutionary changes in parallel, distributed and cloud computing. In parallel computers, the high performance and high throughput computing systems appeared as clusters, service-oriented architecture, internet clouds, peer-to-peer networks, and Internet of Things. These systems were differentiated based on their operating system platforms, hardware architectures, and the protocols used for communicating. In this lesson, let us learn about scalable computing over the internet in detail. Let us now learn what is scalable computing. The more powerful computing capabilities are adapted by the scalable computing, and the scalability is also desirable in the quality of network, process, and website. The computing technology has undergone a series of platform and environmental changes over the past 60 years. There have also been evolutionary changes in the machine architecture, operating system platform, network connectivity, and the application workload. One of those evolutions is replacing a centralized computer with multiple computers to solve large-scale problems over the internet in parallel and distributed computing system. This way, the distributed computing has become data-intensive and network-centric. Let us now learn about the age of internet computing. Billions of people use internet in day-to-day life. As a result, supercomputer sites and large data center started providing high-performance computing services concurrently to huge number of internet users. Because of this huge demand, LINPACK benchmark, which is used to measure the floating point rate of execution of a computer for high performance, became no longer optimal for measuring the system performance. Also, the emergence of computing clouds demanded HTC, that is, high throughput computing system, which was built with the parallel and distributed computing technologies. Data centers are upgraded using fast servers, storage systems, and high bandwidth networks, and the aim is to advance network-based computing and web services with the emerging new technologies. The successive generations overlapped about 10 years from 1950 to 1970. A handful of mainframes, including the IBM 360 and CDC 6400, that is, Control Data Corporation, were built to satisfy the demands of large businesses and government organizations. From 1960 to 1980, lower-cost mini-computers such as DEC-PDP-11, that is, Programmed Data Processor, and VAC series became popular among small businesses and university campuses. From 1970 to 1990, personal computers were built with VLSI, that is, Very Large-Scale Integration Microprocessors. From 1980 to 2000, portable computers and pervasive devices appeared in both wired and wireless applications. Since 1990, the use of HPC, that is, High Performance Computing, and HTC, that is, High Throughput Computing systems, have been hidden in clusters, grids, or internet clouds. The evolution of HPC and HTC systems are illustrated as shown. On the HPC side, the supercomputers are being gradually replaced by the clusters of cooperative computers out of a desire to share the computing resources. The cluster is a collection of homogeneous compute nodes that are physically connected close to one another. Peer-to-peer networks on the HTC side are formed for distributed file sharing and content delivery applications. A peer-to-peer system is built over many client machines and is globally distributed. HPC, that is, high performance computing. HPC systems emphasized on the raw speed performance for many years. The speed of HPC systems has increased from G-flops, that is, gigaflops, to P-flops, that is, petaflops, from the year 1990s to 2010. This improvement was driven mainly based on the demands from the scientific engineering and manufacturing communities. For example, in the LinPack benchmark results, the speed of the top 500 computer systems was measured through floating point speed. Nowadays, the most users prefer desktop computers or large servers for conducting internet searches and market-driven computing tasks. HTC, that is, high throughput computing. There was a strategic change from HPC to HTC paradigm in the development of market-oriented high-end computing systems. The HTC paradigm pays more attention towards high-flux computing. The main application of high-flux computing is the web services and the internet searches can be simultaneously used by the users. The performance goal measures the high throughput or the number of tasks completed per unit time.
This is all about scalable computing users and keyboard and technologies and nowadays users. This is all about scalable computing over the internet. Thank you guys.